Okay, hello and welcome to the inaugural run of this video note-taking method. We'll see how this works, just trying to get you guys some kind of content. I've had a lot of people email, which is great, with questions and concerns, trying to figure this stuff out. So I hope you guys are looking at these assignments. Going forward, however long we're out of school, I'm going to try to use some kind of video software. I'll upload this to YouTube and link it on Classroom. We'll see if that works. But I'm not sure if it's going to work. It's just a recording tool. So I assume you can hear me and you can see my screen as I flip back and forth between tabs. I'm going to try to take these notes and then I'll save them as a PDF so you can refer back to them. But I think the video might help, especially because I've had a lot of people ask questions about the CK12 and it's hard to answer it via email. So I can do these even in the future. If you guys have requests, you can put them on there and I can try to video record my voice over top of it. I can actually record myself, but there's nothing here. I'm currently in my basement in Salesville, Ohio, so not really much to see. So I'll just do my voice and the video overlay. I wanted to talk a little bit about how this will work first. As we go forward through May, I'm going to try to post assignments over the weekend. So like Friday, Saturday, Sunday, I'll either record videos or get assignments ready to push out. And I'll put the due dates as the following Wednesday and Friday. There'll be some other curriculum that you can do, especially going through the text, that you can busy yourself if you would like to have 40 minutes of instruction every day. Feel free to review all of that content. But as far as graded stuff that'll be in progress book, I'm going to keep it to just a Wednesday, Friday assignment for the next few weeks at least until I get other directives. I think that's plenty of work, and it's certainly going to get us through the content that we would have had in Chapter 8, and then we'll call it done at the end of Chapter 8. That said, don't forget you guys have resources. So I think you have the link saved, but I'll show you how to get there. This is our classroom textbook. So if you haven't gone there ever or in a while, you can get there a couple of different ways, but the easiest for us would be for you to open Google Classroom, which I assume you can get to since you've done it all year. For example, first period, I think the best way to get there is to click this classwork tab at the top. I'm not sure if you can see it, but if I do this, you might be able to see that. That classwork tab at the top is the easiest way to get to the most recent assignments. It organizes things, and I labeled it spring break coronavirus assignments. It might well be spring/early summer break, depending on when we go back. But all of these assignments at the top are labeled 1 through 5, and they'll match what's in progress book. There's also a Remind app and instructor email. But just below that is the textbook and resources. Right? If you click this textbook link, for example, it will take you to our online textbook. So if you've never been on that or were wondering where some of these things came from, this is just a compilation of online resources. So they're all there. We're in Chapter 8, the normal distribution. So I click Chapter 8, and you could just read until your heart's content. This is actually not exactly how our notes would have went, but it is a good description of how this content goes. So if you read sections 8.1, 8.2, 8.3, 8.4, for example, it will get you the content. I just clicked a random section 8.2 for an example to show you that it not only has notes, just like a regular textbook would, but as you go down, there's usually videos throughout, right? So this one has a video. You can read the text, you can watch the videos.
If you think about being just one standard deviation from the mean.
She sounds so much cooler than me. Man, maybe you should just watch those. But anyway, you can look at those at your own leisure time. Feel free, that could fill the space if you wanted to look at those on the days that you don't have assignments given to you. But that said, I wanted to make that note. So you do have that textbook resource. For the rest of today, I'm going to try to make 2 videos to start this standard normal curve and z-score stuff. So this will be video 1. It'll probably be about 15 minutes long, and we'll start from here. So let's say the beginning of this notes. So this is the normal curve business. What the heck does that mean? The normal curve. It is a frequency curve. If you're a diehard, you guys could actually take notes along with me, right? I just envision all students at home diligently taking out note-taking type materials so that I can get back into the swing of things and it feels like normal, I guess. I don't know. I hope everyone's doing well. Hopefully you're spending some time with family. I wish I could ask for school-appropriate stories since I've seen you last. That's been a while. Feel free to post comments on this video, and if you have those, good times. But let's say a tough test is given. right? For this illustrative example to try to determine what the heck a normal curve is, the whole title of this section. If you've got some tough test given, and back in the day we had this frequency chart of sorts where this was like the number of people that scored a certain amount, and then their scores were labeled, right? So you could start out a frequency chart here for this very tough test and say that the people that got in between these two ranges got a C, and a lot of people got a C, right? The most of anything. And then the people between these two ranges got a D, and maybe a little bit less than who got a C got a D. So that frequency is a little lower, right? These heights that correspond to the bars, let's say that was maybe, I don't know, 20 people that scored a C. And the height of how many people scored a D, that would be how many people scored a D. So maybe 15. I'm just making up example numbers. But let's say about the same amount scored a B. Oop, that's a 5, not a B. All right. Just kidding. Testing whether or not I can erase. Anyway, and this pattern could continue, right? And so maybe fewer people scored A's and fewer people scored F's. I don't know if I drew that chart backwards now that I think about it, but that's the whole point, is that you could look at this graph and see that there were so many people in each category. And moreover, if you really think about it, you can see the symmetry of this graph, which I think is the whole point of this chapter. More people will score the average score or the middle score of C, right? This column right here is going to be the most often occurring value, the grade of C, like a 75% in this particular test. And then as you move out from the center point, you're going to have an equal number of people to the left of it and to the right of it. And so for this particular model, it's a frequency chart. And from this frequency chart develops this idea of a normal curve or a frequency curve. So let me scroll down. I don't know what you can see on your screen. I'm assuming it's just duplicating mine, but take that same example and pick a prettier color, maybe puke green. And do that same thing, but maybe think about C in this column. And then just to the left of that is maybe a C plus over here and a C minus. And then just to the left of that, maybe a B minus right here, a B plus. And you can see how I'm trying to include more increments, right? A minus, A, and you could go the other way. This was a C minus. I don't know why I put a 1 there. And maybe a D plus, a regular D, a D minus, and an F. And these columns would maybe look like this. It's a really rough chart, but C minus right here, D plus right here, less people got a D, less people got a D minus, even less people got an F. And the same kind of symmetry should happen if you do this test enough times, right? A perfect test, I think we've kind of mentioned this before, a perfect test kind of has this symmetry about it where the most amount of people that you have end up with the middle score, and then it is symmetric about that. And so just as many people got a B, for example, as got a D. And that's because the B and D are equal amounts from the middle score of a C. But now we've got more columns than we had in the previous chart, right? We just took the grade points. Instead of 10-point widths, we put maybe 3 or 4-point widths. But you can see the nature of that graph. Instead of being 5 sections of graph, now we have 9 or 10. And it's looking more smooth, right? Instead of having these jumps that are from 5 to 15 to 20 in frequency, now we have maybe less height between each of these jumps. And if you continue to segment that down, right, instead of grade bands of 3 or 4 points each, you put it down to 1 point or half a point or a quarter point or 0.01 tenths of a point. Eventually, you get a curve that looks more and more and more smooth. And so that is the whole point of this section, is to figure out where that curve comes from. So I'm not sure if I can select all this stuff like I want to and kind of give myself enough space. I want to end up with 3 curves on this chart, on this printout. And so I think I can sneak it in right there. that the last one might end up being more of a smooth curve. Right? That's not perfectly drawn, but that's the idea. And so you can see that this normal curve is just like a buildup from having more and more columns, if you will, more and more spaces to put points. In this test example, this smooth curve is still going to represent the same concept where the middle score, that point in the middle, is like a C value. But more generally, we're going to call that middle score for the rest of the chapter just the average. Right? Whatever you get in the very center, we're going to call it the average. It's the score in the middle. And later on, we're going to call that mu. Right? Oh my gosh, all those gross symbols are still there. What? School's still going on? No. But yeah, that middle score we're going to call mu. And the further you go away from the average, the less likely the score is. Right? So if I take points right here, that corresponds to 2 points on the graph, right? It's a value here on the bottom scale, which is so far away from the average. But it's also corresponding to a height, which equals its frequency, right? How often that score occurred. And so, for example, if this mu was like a 75 down here, and this point was a 70, then this point on the graph tells you that it's a value of 70 and it occurred however many times this height value is right here, right? So let's say there were, 10 of those people, right? So 10 people got a score of 70 is what that point says. And as you go further away from the average, the concept of the first part of this video is just to understand that this point here, way down here, is going to be further away from the average. So maybe this is a score of 60 down here, and less people got that score, right? So maybe this height, this frequency, the number of people that got that is lower. So maybe only 2 people, right? The other point is that there's a symmetric like counterpart on this other side of the graph, right? It will be equal in distance from the average. So this went down 15 to 60, so up 15 from 75 would be like a 90. And that height is also equal to 2, right? It's a symmetric graph. So there'll be 2 people that scored a 90 in this example and 2 people that scored a 60. That amount that you go left and right is the first bit of notes. So the amount that you go left and right on the graph it's called the standard deviation. So we've heard that term before, we've calculated it, and now on these graphs it's going to apply. And so the amount that you jump left and right is called the standard deviation. So we're going to see that in maybe a better example as I look to the next page. So let's start over, keeping that fresh in our minds, but maybe look at a different graph that might happen. So let me call this a shrimp example. I love eating shrimp. A little bit bummed because there's not going to be a shrimp eating contest in my family right now because of this coronavirus business. So I'll just have to eat shrimp by myself awkwardly, but that's okay. I can still do it. Let's say 100 people are in a shrimp eating competition. That's much bigger than ours, but 100 people are in a shrimp eating competition. How much shrimp could you eat? Last year, I ate 225 shrimp in this competition. But that's probably abnormal. Let's say that the average, right, of all these people that were in the competition, let's say the average shrimp ate, like the count of shrimp, I guess, is 50. So let's say there's somebody that ate 50 shrimp on average. That's ballpark average. Normal person eats 50 shrimp in a contest. They can do that. So let me see if I can grab that, maybe move it just a smidge to the left. And then the standard deviation is the other part, right? We said back in the beginning of this class that average isn't enough, right? Now we know standard deviation is a big factor because it tells us how much is normal, right? When you go left and right the standard deviation, it tells you the approximate amount of normal range to expect. And so let's say the standard deviation is 10. With that, you can form a little graph to start to understand this stuff. And then from that graph, I might ask you one question. So let's say this graph is here. We're going to call this the shrimp eating competition graph. And the middle point, we're going to call mu, or the average, is 50. It also occurs the most. So the highest point on that curve is at 50. Then it tells us the standard deviation. So what the heck does this standard deviation tell us? It says that we're going to jump on the bottom scale, the x-axis, 10 units. Each time we write a new number down here, we're going to jump a number of standard deviations left and right. So 10 down is 40, 10 up is 60, this is 70, and this is 30. Again, I moved that much because it told me the standard deviation is 10. So that width is 10. Okay, the question that might go with that. Let's say part A. I don't know if I have more questions than A, but the question is, did more people eat 30 shrimp or 60 shrimp? Right, remember this competition had 100 people. And if you took the average number of total shrimp that they could eat, it was 50. My question is, did more people eat 30 shrimp or 60 shrimp? And how do you answer that question? Okay. Well, you should be able to answer that with the normal curve for this situation, right? It's a frequency curve. So here's 30 right here. It corresponds to this height, whatever it is. And here's 60 right here. That point on the graph is this spot, and it corresponds to whatever height is right here. That was a really poorly drawn line, but you get it. And so the point is, you can call out that more people ate 60 shrimp because that point on the graph is higher, right? And you specifically could be a super nerd and say, well, that's only one standard deviation away, right? You only went one jump this way. Whereas with 30, you had to go 2 jumps to the left. And so it's not a matter of which number is smaller or larger. It's a matter of which number is further from the average. And the standard deviation tells you that, right? If it's 2 standard deviations away, that's further than 1. And so that's the first type of problem I think you can solve, the shrimp example problem. So hopefully you can get that example. These will help you with the CK12 that are either in the past or to come. You can still solve those problems that are on there for the first 5 assignments because it tells me that you did that in an email. But I'll be posting probably assignment 6 will be the vocabulary, like a Quizlet where you just have to go through and do them. That'll be an easier one. And then assignment 7 is another CK12. So you'll see that posted either today, tomorrow, or Sunday. And they'll be due, assignment 6 will be due Wednesday next week. Assignment 7 will be due Friday. And so we'll continue with that. To finish this video out, I've got maybe another half page. So let's call it the standard normal curve. Let's see what the heck that is. And then we'll end there and maybe do some examples on the next video. So standard normal curve versus normal curve, right? Normal curve was just everything is nice and symmetric. You get this picture that the most number of things occurred in the center and it's symmetric out from there. And the magic normal curve situation is like the shrimp example that we just looked at. Okay, what's a standard normal curve? Well, it's just a special case where they say the center, gosh, I could probably draw it roughly here. I'll bring in a picture from the textbook that's better, but the middle is just 0. And we're going to call the middle point mu, right? And so the center of a standard normal curve is just the special normal curve, a frequency curve where the mean is 0. The center, or mean, is 0. Mean of 0. And then the standard deviation is the other part you always find out. So the jump distance, right? Like our shrimp example was 10. The jump distance or standard deviation is just 1. It's exactly 1 unit. So this box kind of describes a standard normal curve. And so if we're going to put those little spots on there again, right, this is 1, 2, 3. And since we were at 0 and the standard deviation is 1, if we went backwards, it goes to -1, -2, and -3. And this is the prototypical picture that you get with a standard normal curve. It just is an example where the mean is 0 and standard deviation is 1. Right? Maybe my drawing's not quite beautiful. Gosh, all of the really cool statisticians in the world would look at this and say it's terrible because they should be symmetric, right? As I go through this height of 1 should be the same height as -1 on the left side, right? So it looks pretty good there. But in general, that's the standard normal curve, right? And the big concept is, like, skipping all of the calculus and fun stuff behind there, but the big concept is that the area between any two numbers, right, the area inside the curve represents the percent of values between any two numbers. Let me get that jotted down and then I'll talk about it a little bit. The area inside the curve represents the percent of values between any two numbers. For example, on the standard normal curve we have above us, if you found like the area of this green shaded region here, it would tell you the percent of people that got a score between 0 and -1 in this specific example, right? And so it might be like 34% or whatever it is. And so that said, the area under the entire curve always represents 100%. And then you can find pieces of it. In fact, that's the title of a section that you were supposed to have read in an assignment that said empirical rule, right? If I go back to, I think it's assignment number 4, it says the empirical rule in 5 minutes, study these terms. By the way, assignment number 4 on Google Classroom, all you have to do is click that you have read it. And so there's no reason for these to not be done. Hate to call out those students, but you can just literally click that assignment, read through those, and then click submit on Google Classroom and get the points for those. But assignment 5 is also there, right? It's the empirical rule. It links to the chapter text where you go through that with some CK12 examples. And so that said, this is going to apply to that section if you'd like to look at it. I'm going to try to sneak it onto a third page so it's not too long, but let's look at that empirical rule. Let me see if I can write that here. And finish the notes with this. The empirical rule is probably best shown from the textbook. I think I can grab a picture somehow. Sorry you have to watch me do this, but I'm sure we'll get it figured out here. And this picture is the empirical rule, right? Trying to click to drop. There we go. Okay, so looking at this picture, the only thing it doesn't have is the number of standard deviations, but it's the same thing we just did, right? Right here is -1, -2, and -3, right? Back one standard deviation, a second one, a third one. The middle is 0, or the mean, and then these go up 1, 2, and 3 standard deviations. It's the same exact graph that we have up above, but it has the percentages in there. And as it turns out, there's this rule that says basically if you're within 1 standard deviation, right, this section here, the purple region on the screen, it's always going to represent 68% of people. So if you had a test that you could get an average score of 0, then 68% of people would get between a -1 and 1. It's kind of a tricky example because tests don't usually go on that scale, but that's the general concept. If you apply that to our shrimp example up here, very, very, very roughly, then it would say 68% of people are going to eat between 40 and 60 shrimp. Right? That would be the empirical rule explanation for the shrimp example. 68% of people are going to eat between 40 and 60 shrimp. Now, that may or may not be the case in the shrimp example, but that's what this empirical rule kind of starts out with. And so seeing that helps you understand these further examples. This is called the 68, 95, 99.7 rule. And those three numbers essentially can get you all of the percentage answers for section 5 assignment, the empirical rule, as well as a few on number 7 and 8 that are coming in the future here. So this is the 68, 95, 99.7 rule, called the empirical rule. It means that between one standard deviation, the purple region, there is 68% of people. If you go 2 standard deviations, meaning you jump twice from each side of the average, it's always going to get this 95% of people, right? The purple plus the green. And then if you go 3 standard deviations, it's going to be almost everybody every time, right? 99.7% of all people that have ever done whatever experiment you're doing should fall within 3 standard deviations of the average. And that said, it lets you make some implications about the rest of the graph. Oh, that was terrible. Come back. It lets you figure out these smaller sections. So sorry for erasing that, but you can figure out that, let me draw on this a little better. There are 34% of people within one standard deviation, either left or right, and 68% altogether, right, if you add 34 and 34. Between 1 and 2 on the positive side, there's 13.5%. And between -1 and -2, and so on, right? You get all these sections. That's why all those separate percentages are in there. And so that graph is essentially the answer to a lot of questions. Let me give you one example. I'm at 27 minutes. Gosh, so we're a little bit over my 20 minutes that I thought, but that's okay. Example 1, and we'll stop there. Let's say, for example, you had a mean of 30. So if the mean is 30 and standard deviation is 10, my question is, what percent of values are from, and let me give you several different examples, so are from 20 to 30? What percent are from maybe 20 to 40? And what percent are from maybe 0 to 60? If the mean is 30 and standard deviation is 10, what percent of values are between 20 and 30, 20 and 40, and 0 and 60? So you don't have to draw this every time, but if you did just draw the number line, it would help you to get the empirical rule answers for this question, right? If the middle is 30, that's the mean. The standard deviation tells you how many jumps to go. So I'm going to go to 40, 50, 60, jumping by 10, because that's what the standard deviation is. This is 20, 10, and 0. First question says, what percent of values are from 20 to 30? Right? Remember, this is the center point. Well, from 20 to 30, it's only one standard deviation to the left. If you look at the picture above, it's just this zone, right? From the middle, it's one standard deviation, one jump to the left. So that's 34%. The benefit about having a video is you can stop and go back, and if you have no idea what's going on, that's kind of nice. So I'll go on from 20 to 40. So how many people are from 20 to 40 on this particular example? Well, that's one standard deviation left and right. And so that's the 68, right? We jumped one standard deviation left and right, or 34 plus 34 is 68% of people. And last question, so now you go all the way from 0 to 60. So what percent of people went all the way from 0 to 60, meaning, gosh, 1, 2, 3 standard deviations left, and 1, 2, 3 standard deviations right? That is this 99.7 number. You can also look at the graph above. You could technically add 2.35, 13.5, 34, 34, 13.5, and 2.35 again. But that is one example of how you could use the empirical rule to answer a simple question about like percentages. I'll move on from that, but I will stop there. So that was a good first video. Sorry if it was a little bit long, but hey, it was less than a period, and it's the only lecture you've had for the past 3 weeks. So rejoice! I hope this goes well, and I hope this video uploads. So otherwise, please send questions, comments. If you know any other video editing software that might be better, let me know. Otherwise, it's been fantastic. Talk to you guys later.